All right, this is the last grade for this marking period. This project's report will count as a test grade. The due dates are listed at the top there. It's named Stroop Effect, named after an American psychologist who researched cognition and interference. So let's read this paragraph. In psychology, the Stroop effect is a demonstration of interference in the reaction times of a task. So for example, we could have the name of a color, blue, green, or red, printed in a color not denoted by the name. So for example, the word red could be printed in blue ink instead of red ink. So if that's the case, naming the color of the word takes longer and is more prone to errors than reading the word and just ignoring the color that the word is printed in. This effect is named after Stroop, and he first published his report in the 1930s, almost 100 years ago. Okay, so setup. You can work by yourself, you can work in a group of 2 or a group of 3. Regardless of how many people you're working in your group will return in one report. It must be typed. Graphs should be generated in something like Excel. Worst case, if you can't figure out anything else, I've had kids in the past take a picture with their phone of their graphing calculator and then crop it and insert that into their document. That works. It's down and dirty, but it's okay. All right, so the objective. You're going to design and execute a randomized experiment in which you collect and compare analyze data in the time needed to perform 2 tasks. So the 2 tasks are: 1, read as quickly as possible a list of words ignoring the color in which the word is printed, and then B, number 2, say as quickly as possible the color of a list of words ignoring the actual word. So this probably makes no sense having read it, but if you look at this list you can kind of see. So for example, you would flip a coin to decide is the subject going to read the words first or say the colors first, and I'm just going to do, so like I flip a coin and I read the word, so I say blue, I see red, green, yellow, blue, and so on. And the data that I'm giving you used 2 columns, but you know, if you were going to do it by yourself, you could do whatever you want. But since I'm giving you data, most of the data is using 2 columns. You want to continue with that if you decide to create more data. And then after that, you're going to have the person say just the color. So looking at this column, I would say red, green, blue, blue, yellow, red. That tends to be slower and more accident prone. Okay, so you're going to record the time required to do both those tasks, and if you're going to do it by hand. So let me just go into more details. Due to social distancing, the collection of data for this experiment is more challenging. As a result, I am supplying you with data from 20 individuals. This data was collected in a past year. These subjects read the word and name the color. The order of the task is randomized by flipping a coin. Say heads is you read the word first, and tails you would say the color first. All right, extra credit, increasing the number of subjects. This could be done virtually by sharing your computer screen in something like Google Meet. Will gain you extra credit for this project's grade. So in other words, you could just use my 20 data values. Those 20 data values are on page 3 listed here. Okay, so the time in seconds to the nearest tenth of a second for reading the word and for naming the color. Okay, so you can use those 20 without any repercussions and not collect any data yourself. But if you collect data, you need, you know, the details are here. If you need, if you're going to collect data, you need 5 extra data values for each person in your group. So working by yourself, you need 5 more, or 25 total. And then this extra data will be just added to the bottom of this table. You would have to reproduce this table in your report and then add your extras at the end if you decide to use extras. Okay. All right, so you're going to do an introduction. Explaining similar up to what I did up above, who Stroop was, and you know, a background and a history of that. So you're gonna ask 2 questions. So these are the questions you're investigating. Do you see data? Do you see evidence of a difference in the time required to perform the 2 tasks? So the 2 tasks are the time required to say the color, and then minus the time required to read the word. So this would be a mean of the difference in the two times. So this is a matched pair t-test, not a difference in two means. So we don't have two samples, we have one sample. Also, it's not a random sample because this is an experiment. You're randomizing who does which task first. So that's where the randomization comes in. All right, the second question is, do you see evidence of a linear relationship? So that would be chapter 12, right? 12.1 is we were testing hypothesis for slope, and that's what this is. So would the slope be greater than 0? Or not equal to 0, I guess, would really be the thing you want to look at. All right, experimental procedure. If you're collecting data, then you should explain how you're collecting the data and that kind of thing. Pretty much talk about how you randomize, decide who does which task first, and so on. But the majority of the people doing this are going to be looking at the write-up. That's the most important part because, again, if you're just using my 20 data values, you don't really have to explain much of your experimental procedure. All right, you should include the raw data in table form. So reproduce the data I gave you and then add to it whichever data you're using if you're creating new extra credit data. All right, one at a time you'll answer the questions up above. And that will be in the form of statistical inference. You will use your 4 steps: your state, your plan, your do, your conclude, backed up by the collected data in the form of graph whenever necessary. This should include statistical analysis, checking and verifying all conditions. All right, if you come to a particular condition, so in other words, let's say the data, you do a scatter plot of the word time versus color time and you see that there's a curve in the data, well, obviously we would not proceed with it. So if the condition's not met, you would just, for the purposes of this, you would note that concern and say that the condition's not satisfied, but continue with the project, with the process. So don't just stop your report. I would expect you to still do your do and your conclude, even though your conditions are not met. I would suggest that before you begin anything in this project, you read through the rubric on page 4. So on page 4, we have the rubric, all the points. Notice some of these points you already have because I've given you the data, so there really isn't, did you use enough subjects? Well, I gave you 20, so that's all you have to use, so everyone's going to get those points. So that's why these points are already listed up here. All right, so look through the rubric, all right? This is for question 1, it's the matched pair t-test. This is for question 2, this is the inference about slope, right? So make sure you're doing that. You'll notice these first two items, this first item, hypothesis, so this is the null and alternative hypothesis. You're going to list what those symbols mean, though, and explain it in the terms of the population. All right, this sounds a lot like what procedure we're using, right? The first part of the plan, the conditions, that's the second part of your plan. Calculations, that's the do, a part of our 4-step process. If you're using your calculator, that's fine. Tell me what test you're using in your calculator and record all the pertinent information that your calculator gives you in your report. And then the last part is your conclusion, stated correctly. All right, so remember your conclusion typically has 3 parts. You're comparing your alpha to your p-value. You are deciding whether you're going to reject or fail to reject the null hypothesis. And you would then say something intelligent about the alternative hypothesis. All right, and then you do the same thing for question 2. Go through the 4 steps. Remember that is for inference about slope. So you have a possibility, a total of 100 points and 5 extra credit points that are possible for this project. Remember, this project counts as a test grade. Again, do not wait till the last minute. If you're in period 3, it's due on the 17th. Don't wait until the 16th to start this project. You're going to have all kinds of questions and you won't have time to ask them of me. If you're in period 6 and 8, yours is due on the 18th. Don't wait till the 17th to start this project. You will not have time. If you're going to work with other people, that's fine. But if you're in period 6 and you're working with someone in period 3, don't forget theirs is due on the 17th, so everyone has to be due on the 17th. You will lose a point for every day that it is late. So don't be late. And then also, if it's late, I mean, I don't know when grades will be due. This is already 17th and 18th is already at the end of the year, so we may not even have many days after that. Okay, you'll turn this in with a Google Classroom post. I'm going to do this one as a this video viewing will be as an ed puzzle. That will be due as a watching it will be a homework grade, and then I'll put another post up for the assignment to actually get posted, your project to post to.